here is another example. You can find the example on page 2. On page 246, solve graphically. So you're given a system of two equations. F of x equal to negative 3x plus 5, g of x equal to negative 3x negative 2. Solve. Again, when you solve a system of two equations, these are the three possible cases. So let's solve it. It asks you to graph it, right? So same procedure. Now, let's see, solutions. If you recall, f of x is just like y. So let me just simply write y equal to f of x equal to negative 3x plus 5, y equal to g of x equal to negative 3x negative 2. They are different y, okay? They're not the same thing. But yeah, you can call it y or you don't have to. So let not, okay, just to avoid confusion, but they represent y. The two y's are different, okay? Because this y represents f of x, this y represents g of x. But let's keep it as f of x, g of x, just to help you see what it means. It looks fancy, but all it means is y. The two y's are different, okay? Alright, to graph lines, you need to find 2 points. Let's have this table for this f of x, okay, which equal negative 3x plus 1. Let me not writing it, just this, say spade. This table for g of x, okay. Let's find 2 points only. You can find more, it's better, but I'll just do the minimum. When x goes 0, you substitute to f of x, okay? When x goes 0, you substitute to x, it becomes f of 0. So f of 0 means you replace all the 0 for x. So x happened again right here, right? That means negative 3 times 0 is 0. 0 plus 5 is 5. Okay? Same procedure. X go 1. Substitute for f of x, you have f of 1. So what is f of 1? F of 1 is here. So replace 1 for x. So x is right here, so replace 1 here. Negative 3 times 1 is negative 3. So negative 3 plus 5 is 2. Okay, so let me check. 0, you have 5. 1 here. Negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. Okay, it's good to double check. When x goes 0, you have negative. When x was 0, substitute x was 0 to here, so you have g of 0. The g of 0 right here, replace 0 for x, so replace 0 here. 0 times negative 3 is 0. 0 subtract 2 is negative 2. Same thing here, substitute 1 to x. G of 1, replace 1 for x. So 1 times negative 3 is negative 3. Subtract 2 is negative 5. So work it out. If you don't see this, understand. You don't see it, you can work it out. And I show you all these steps in I believe section 2.1. So I'm not going to show you all the steps again. If you have questions, you can go back to section 2.1 in chapter 2. Alright, now we have all the points. Let's graph it. This color is not very good. X, Y, okay. So when x goes 0, y goes 5. So 1, 2, 3, 4, 5. So this point right here, 0, 5. When x go 1, y go 2. So x go 1 right here, y is 2 is up here. So 1, 2. If you have 2 points, you can grab a line, and this line go through the 2 point. Okay. And notation y equal to, or call f of x. This label f of x. For g of x, you have 0, when x equals 0, y equals -2. X is 0, y is -2. So this point right here. So 0, -2. When x equals to 1, y equals -5. So 1, 2, 3, 4, 5. Somewhere here. So this point is 1, -5. Okay, 1, -5. Now, let me use different colors. So you grab it, connect 2 point. Now, what do you see? Let me label it g of x. Okay. Do these two lines intersect each other? Mm-mm. So which k is that? Not k is 1. K2? Yep, they're parallel. You see that? So what does it mean with parallel? If you read case 2, it gives a description of case 2. Two lines are parallel. There's no solution. Okay, so let me just say, thus, let me erase it, okay? You say thus, there is no solution. Okay, this is K2. That means that the lines never intersect each other. Now, if I ask you, does this system of two equations independent or dependent? Remember, you can review that to say that the graphs, the equation are different lines. So these are different lines, right? They're going to be independent. So you say the system is independent. Okay? Now, what if I ask you consistent? Does the system consistent or inconsistent? Now, again, if you're not sure, look at case 2. What does it say? The system is inconsistent. Why is that? Because to be consistent, it means the system must have at least one or more solutions. There's no solution, that means it is inconsistent. So a question, go back to definition. So we would say that the system is inconsistent. Okay, inconsistent. So this is the solution for this example.